Example 7. A piston cylinder with a cross-sectional area of 100 is connected with a hydraulic line to another piston with a cross-sectional of the 500 meters square as shown in this picture. We have area, and the area of this piston is so small. Piston area and the bigger area is assume that both chambers and the line are filled with hydraulic fluid of density and the larger second piston cylinder is 6 meters higher up in elevation. In this picture, H 6 meters. The telescope arm or the buckets have hydraulic piston cylinder moving them as this picture with an outside atmospheric pressure (100 kilopascal) and a net force of the telescope arm and the bucket have hydraulic piston moving them as this picture with an outside atmospheric pressure of 100 kilopascal and a net force on F1 25 kilonewton on the smaller piston. What is the balancing force? That's the second. We know that for the system of piston and these have this from our noun we can calculate the P1 pressure because we have F1 and also we have the P0 in this point. In this point we can write P1 equals to P0 plus F1 on A1. In this case P1 can be calculated and is 100 kilopascal for the P0, for the force kilonewton, and the area of the smaller that was 100 meters square. So the magnitude of the pressure kilopascal. For this point we have P1 and P2. We can write the relation for the pressure. P2 is the pressure. Let me write P1. Pressure at P1 equals to P2 plus the pressure due to the column of the liquid, rho GH1. So P second or P2 I said minus rho GH1 Now we can calculate P2, P1 minus the density of the hydraulic fluid multiply the gravity acceleration and multiply the h, which is 6 meters. To convert to the kilopascal, we should divide to 1000. Now the p second can be calculated and is kilopascal. So we have also the relation for the point second. The second point p second should be equals to p0 plus f2 on a2. We had just calculated the pressure. We just calculated the pressure at point 2 equals to P0 kilopascal plus F2 in Newton, in kilonewton, A2. So F2 equals to 8 second multiply to that we can calculate it and is kilonewton. Which is about 5 times greater than F1, the mechanism of an hydraulic accelerator.